Hey again, Anakwe. How are we doing? So going back today, what we're going to do is we're going to review integers, adding, subtracting, multiplying, and dividing. Last week we looked at linear equations, all with positive values. Today we're going to look at linear equations with negative values. But before we do that, we're going to review a little bit about how it all works, because we have to know how to work with negative integers, both addition and subtraction, as well as dividing and multiplying negative integers. So we'll go back to adding and subtracting. You guys remember from a couple of weeks ago, we talked about when we're adding and subtracting, there's certain functions that give us different results. So we talked about we have -6 and we add 3. We're taking something cold and we're adding 3 hots. So that's going to make the temperature rise from -6 to -3. Band-Aid coming off, no big deal. -6 plus 3 is -3. It's going up in temperature. We added 3 hots. Here, -6 minus 3, we're taking away 3 colds. We're subtracting something. We're subtracting some cold. So -6 minus 3 is going to get colder. We're going to end up at -9. Okay? We're subtracting 3. It's going down. Okay? The temperature's going down. It's dropping 3 degrees. Here, we're subtracting a negative. Right? I'm taking away something that is cold. I'm not taking away something that is warm, positive. This is also the same, -3 minus +3. We'll get to that in a second. It's the same thing as saying that. This is saying I'm taking away something that is cold. Note that's why the brackets are important. So -6 minus -3, if I take away something that is cold, if I remove 3 pieces of ice, the temperature is going to go up. So maybe the trickiest one to remember. Another trick, you guys remember the trick, is to just think of this -3 as one big plus sign. There, right? So -6 plus 3 rather, is -3. Okay? It's the same as when I add 3. I'm taking away 3 colds. And this one here, -6 plus -3, I'm adding something that is cold. I'm adding 3 ice pieces, so it's going to drop in temperature and end up with -9 again. Okay? So those are the functions of addition and subtracting, of adding and subtracting integers. Notice I started with a negative number here, so you can get that idea that you can still have a negative number, right? When you're adding something warm, if the negative number doesn't exceed, if you're not getting past 0, right? So -3 is warmer than -6, even though it's not past 0. That's just something to remember. Okay. So pause that. If you want to copy that down, you can pause the video now and copy it down, just to have it with you when we're doing the homework that'll be assigned there. So there you go. Now, review multiplying these. I see that Rowan has drawn something. I don't know if you guys can see, but she's drawn something here. Okay. So let's review multiplying and dividing. So remember we built that table a couple weeks ago. So kind of looks like something like this. And you think of it as like a square. Comme ça, voilà. So this works for both addition and subtraction, multiplication and division. Okay. So whether we're multiplying or dividing, these rules, and these rules only apply with multiplication and division. Right? We just had a negative plus a positive, and it still gave us a negative number, right? We had -6 plus 3, it gave us -3. But if it was -6 plus 9, it would give us +3. So these rules do not apply with addition. It only applies to multiplication and division. It's like a common mistake that we've seen over the years. So positive times a positive gives us a positive value. Positive times a negative gives us a negative value. A negative times a negative gives us a positive value. And what's the one I'm missing here? Actually, this one would be, negative times a positive, I know what's wrong. There. So a negative times a positive, is a negative value, and a negative times a negative is a positive value. So your square looks like this. This is negative times a negative gives us positive. Negative times a positive gives us a negative. So basically, if the signs are the same, my brother-in-law is calling me right now. I don't know if you can see that on the screen. It's saying Mike Bishop calling. I'm going to ignore that call. So if the signs are the same, you're going to end up with a positive result, okay? So again, pause the screen. You can have a look there. All right. Okay. Today's work. My notes. My notes, my notes, my notes, notes, notes. I'd worked this out in my head, so I just want to make sure that I actually get the right answer. There we go. So last week we looked at an expression like this. 2y plus 3 equals 9. Okay? And we looked at how to do that. Why don't we solve this one right now? A really cool way to know if you're getting this is if you can create them in your head as you're writing them, right? Or if you can create a balanced equation, then that's pretty cool. For example, the number 10 here wouldn't work because, you just think, yeah, it wouldn't work. If I were to put a 10 in here, I'll show you what I mean. It's good practice. So 2y plus 3, so I'd be stuck over here. Let's just pretend to solve this one. This is not a balanced equation, or we're not going to get a whole number here, and I'll show you why. So we're going to get rid of our 3. Plus 3, we're going to take away 3, we're going to get 3 here. So we're going to end up with 2y equals 7. And now you can maybe see, right, I'm going to end up having to divide 7 by 2, right, which doesn't work into a whole number. I divide 2 by 2 on this side to give me 1. 1 times y is y. That means I got to divide by this, right? I got to balance the equation on both sides. So y is equal to 7 divided by 2, which is 3.5. So it doesn't give us a whole number. And because we like to work in whole numbers, it's generally a good exercise to see. I'll write the whole expression again. It's a good exercise to see if you can create them on the go, like I just did. So 2y plus 3. So in my head, I'm thinking, okay, like this could be 3, right? Because 2 times 3 plus 3 equals 9. That's a whole number, right? So you're sort of thinking about the problem backwards that way. I could also make the value. What else could I make it? Let's say if I made it 4, what would it be? It'd be 11, right? Because 2 times y would give us 8. So this is a balanced expression. Now we're going to solve, and we're going to figure that in this case, y would be equal to 4. So I got to add 3. I've got 3 here, so I got to take away 3. This is still a review from last week. And if you're not sure, but you can go back and check the video from last week too, because it'll sort of break this down maybe a bit more slowly for you. So if I subtracted 3 on this side, I got to subtract 3 on that side to keep it a balanced equation. Remember, the sign means that it's the same. These two numbers are the same. They're just expressed differently. This number is expressed as 2y plus 3. This is expressed as 11, but they both mean the same thing. So in order for that to happen, if I take away 3, that means we got 8 on this side. I got to take away 3 on that side to keep it the same. So 11 minus 3 equals 8, and now I'm left with 2y. 2 times y equals 8. Now you're like, right, I get it, it's 4, right? But just to be sure, we're going to do our work because down the road it gets more and more complicated. Remember we talked about that last week, how in math in Ontario, we build like from a very basic foundation, and we build on top of that. So the foundation has to be stable, or else the house kind of collapses. Metaphor. Divide by 2 to get y by itself. 8 divided by 2 equals 4. Y is equal to 4. 2 divided by 2 is 1. Y. 1 times y is y. Okay, so that's why we divide on the other side too to find the value of y. Let's just do it a little differently now. Just a slight variation for this week, and I'll post some problems. I know Junior was asking about it earlier this morning. Okay. Now I'm going to have a negative leading coefficient. Waving to my neighbors. Negative 2y plus 6 equals 16. I think one of my neighbors is walking up to our house. Prepare for the dogs to bark loudly. Killers of things. Okay, so here I've got a negative leading coefficient. I just have to remember that eventually I know I'm going to be dividing that, right? So that's why I have to go back to my, what do I do when I divide and multiply integers? So I'm going to, same thing as I did before, I'm going to get rid of my positive 6 first. So I'm going to subtract 6. I'm going to subtract 6 on this side. So I end up having, that's 16, that's going to give us 10. I have negative 2y equals 10. How do I get negative 2 by itself? I don't divide by 2, I got to divide by negative 2. Okay, so when you take a negative number, minus 2, and I divide by a negative number, minus 2, I'm going to get a positive number. Right, that's that weird thing we just went over. Negative 2 divided by negative 2 equals 1. 1 times y equals y. Over here, I have to divide by negative 2. Remember I said I would. Negative 2. What's a positive? Positive 10 divided by negative 2. Positive 10 divided by negative 2 is going to give us positive divided by negative. It's going to give us a negative number. That's why it's important to remember that. So see how, like, that's just an example how something we did like 3 weeks ago is important later on in a different lesson, right? So y is going to be equal to 10 divided by negative 2. That's going to give us negative 5. Y equals negative 5. Let's test it. So negative 2 times negative 5. Because remember that leading coefficient, that means 2 times y. Right, that's just saying 2y is the same as saying 2 times y. So it's saying negative 2 times y. The value is negative 5. So what's negative 2 times negative 5? Negative times negative equals positive, right? So that gives us 10. 10 plus 6 is equal to 16. So we know we're right. So I'm posting today work with negative. This is called a leading coefficient. You can just call it the first term. Yeah, because it's the first term in that expression. And Mr. Webster will be the guy to tell you all about why that's called a leading coefficient. So I'll post work on this. If you want to review work before, if you're looking at this and you're like, whoa, 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 go back to the videos at the start. You can. That's the cool thing about this is you can review the lessons as often as you want. Which is, you know, like if you're, like let's say Reza was poking you with a pencil and you missed something, and you're like, hey, the Black Prince, stop that. But now you can just review it, right? You don't have to be like, hey, Mr. Brown, get Reza to stop poking me with a pencil. Okay, so I'll post work with negative leading coefficients, examples like this that you guys can work on. And again, remember to email me with your questions. Also remember that we're taking up our book tomorrow at 1 o'clock. Today's Thursday. Tomorrow we're taking it up at 1 o'clock in our chat room. Okay. Au revoir, les amis Brown.